Hi everyone, my name is Vanessa Lee, and today I'm going to be talking to you about sound pollution in the marine environment and how this affects bottlenose dolphins. So first, a little bit about my project. It really stemmed from a passion for animal welfare that I've had since I was little. Dolphins have been my favorite animal for a long time, and I'm always fascinated by their individual intellectual abilities as well as group dynamics. So this project was a fun way for me to combine my interests of animal behavior and environmental activism. So let's get into the research. First, I would like to introduce to you the various types of dolphin communication, and they're usually categorized into three groups. The first are whistles, which are long and high-pitched, and typically used for group cohesion and hunting activities. Dolphins also have a special signature whistle, which is like their individual name. Clicks are short and high-energy pulses of sound, usually used in navigation and echolocation. Lastly, burst pulse sounds, sets of rapid and loud clicks, are used for direct or short distance communication. Here's a clip of what each vocal signal sounds like. So with these vocal signals, dolphins are able to find food during hunting and foraging sessions. However, methods vary based on location around the world. For example, in Australia, bottlenose dolphins use sponges to dust the ocean floor and displace prey hidden within the seabeds. Then they use echolocation to determine the exact location. In South Carolina, the pods work together to simultaneously beach themselves and herd fish onto the shore. But perhaps the most communication necessary technique is the drive and barrier method. This is where the pod assigns roles so that one dolphin uses tail slaps to herd a school of fish towards the other members, who create a barrier. When the fish jump out of the water to avoid the barrier, the dolphins are able to feed. However, a posing threat to dolphin communication and hunting is anthropogenic noise, and this is not natural ambient noise. Anthropogenic noise originates from man-made sources, including commercial ships, seismic exploration devices, sonars, and offshore drills. With this information, I created three main hypotheses. First, increases in the amount of anthropogenic noise will negatively affect dolphin communication. Second, dolphin acclimations to increased anthropogenic noise will lead to negative effects on dolphin welfare. Third, reduced noise pollution will have positive effects on dolphin communication and welfare. So for the first part of my project, I studied the effects of anthropogenic noise on dolphin communication. One study presented dolphin duos with a task in which they had to coordinate the pressing of two buttons on opposite sides of the pool. Vocal recordings reported increases in whistle production right before the pressing of the button. This suggests the pairs were using acoustic signals to coordinate their movements. However, when anthropogenic noise was introduced, the success rates declined. This may extend to the hunting abilities of dolphins and reduce the fitness of these dolphins. Many researchers have found that in the face of anthropogenic noise, bottlenose dolphins have been able to make changes to their vocal signals in order to adapt. This includes increasing the frequency of vocalizations, since anthropogenic noise is typically at a lower frequency. However, bottlenose dolphins are versatile in that they are able to lower whistle frequencies in the case of high-pitched anthropogenic noise. They are also able to reduce the complexity of their whistle contour being the varying frequencies of each whistle. Increasing amplitude has allowed the dolphins to transmit messages over the volume of anthropogenic noise, and simplifying calls has allowed dolphins to convey shorter messages in periods of low to no anthropogenic noise. In cases where this noise has impacted the ability of dolphins to coordinate tasks, the dolphins would adjust their vocalizations to compensate. For example, in the previously mentioned coordination study, both dolphins significantly increased amplitude of their whistle in response to higher levels of noise. However, these adaptations come with negative consequences. The vocal adjustments dolphins make in response to anthropogenic noise requires increased vocal effort, which is the total acoustic energy of sounds produced. This results in a higher metabolic rate, or the amount of energy expended, relative to that of resting states, as much as 1.2 times the resting rate. In addition, the simplification of whistles between individuals can result in reduced information exchange. And this is a major concern when considering young calves, as they may be raised with inadequate vocal learning when they are exposed to the modulated sounds instead of proper ones. There are also concerns that vocal adaptations cannot address. For one, the same study completed on coordinating dolphin dyads showed a drop in success rates by 20% when anthropogenic noise was introduced. And this is even after the dolphins attempted to increase whistle amplitude. Coordinating hunts may therefore be inefficient or unsuccessful despite their efforts to adjust. In addition, bottlenose dolphins may move away from areas of high anthropogenic noise, such as boat docks or shorelines, which forces them to seek food in unfamiliar and possibly dangerous areas. The encroachment of human activity on bottlenose dolphin habitats also poses a concern for general habitat availability, one that cannot be solved by the dolphins themselves. With this human activity comes water pollution and motor noise that can cause deafness in the bottlenose dolphins. So, what are some possible solutions? One suggestion is to enforce slowdowns, which are legally enforced speed limits for watercraft in specific areas, especially ones with large wildlife populations. Across all frequencies, there has been observed lower sound production and a smaller acoustic footprint with slower speeds. Although some argue that slower speeds increase the amount of time spent in marine habitats, the most important thing is that slowdowns actually reduce the overall time during which marine life is exposed to and is affected by the noise over an ambient noise level. Another possible solution is the implementation of new technology, such as the electric-powered engine. And this is more sustainable than the typically used internal combustion boat, which uses gasoline and produces high amounts of air pollution. In contrast, electric-powered engines use solar energy. However, the most effective measure would be to enforce both slowdowns and technology, such as electric engines. A combination of these methods would be the optimal solution for this prominent environmental issue, as it effectively minimizes interference with bottlenose dolphin communication. Therefore, through awareness, technology, and policy implementation, humans can successfully reduce anthropogenic noise from marine mammals, such as bottlenose dolphins, to ensure their well-being and survival. Thank you.